Hey everyone, my name is Ethan, and in this video we'll be covering variables, inputs, data types, and operators. In each video, we will have some topics to cover as well as vocabulary, which can be seen in this first text cell. Then we will also do a few more examples that pertain to the topics. As you may have noticed already, we're not in a Python file in Visual Studio Code. This environment is called Jupyter. The only difference is that I can put text in cells for examples and vocabulary. We'll have a separate tutorial for setting up Jupyter if you want to follow along directly, but I would just recommend setting up a file in Visual Studio Code and following along for each example. If you're confident in the material, pause the video and attempt the problem first, and come back and see if you did it correctly. Let's get started. The first thing I want to talk about is expressions and statements. An expression is a value or anything that executes and ends up being a value. In this first code cell, 3 plus 4 is an expression because it ends up being 7. Now, the interesting thing about Jupyter Notebooks is that if I run this, it will print out 7. This is not the normal behavior, and this won't happen for you if you're just in a normal Python file. This is useful in Jupyter Notebooks, however, because Jupyter Notebooks is used for data analysis and data science, where sometimes you just want to print something out like that. However, we want to use a print statement and put the expression inside and print it out that way. And I'll be doing this to stay consistent. Also note that we have an expression 3 plus 4 inside, which makes up this entire print statement. This is in line with our definition of a statement, which is a group of expressions and/or statements that carry out a task or an action. It's a complete logical thought in a program, and it's usually a single line of code, which checks out here. Okay, so our first example says to write a program that takes two integers as user input and exponentiates the first to the power of the second. So the first thing I want to do is make a variable. I'll name it base, and I'll use the equal sign, which is the assignment operator, to assign it to the value of the user input, which is the input function here. We can pass in a string to the input function, which is printed out to the user before they input anything. So we'll say enter a number to exponentiate. And now we need our second integer as user input. So let's do the same. I'll name this one power. I'll take an input, and I'll print out a nice message to the user. Next, we could, as mentioned, just put this whole expression inside of a print statement, but sometimes it's more useful to have a separate variable outside of a print statement, just in case you'll use it again in your code. We'll do that here. So we'll say result equals base, and then hopefully you remember the exponentiation operator. It's 2 stars, base raised to a power, and then we'll print that out. Let's try and exponentiate 2 to the power of 3, and this gives us an error. So hopefully you've seen an error as well just by playing around in Python, but if you haven't, here's what they look like. It's typically a box, and it does look kind of scary because there's a lot of red and there's a lot going on. In time, you'll learn to just filter out the irrelevant details and focus on what matters. So in the top left of the error box, at a glance, we see it's a type error. We also see traceback in the top right. We know exactly where it is, and if you're in your normal Python environment and not in Jupyter, it will still say the line. And it even points to the line and highlights the issue. Now really what you want to check out is the description at the very bottom of the error. It says type error, unsupported operand types for the exponentiation operator, string and string. Now these messages are a little cryptic and take a while to get used to, but what this one is saying is that we're trying to raise a string to the power of another string. And that doesn't really make sense, right? So the root of this issue is that input always gives us a string because the user is entering text on their side. So we need to convert this to an int. We can do that with our type conversion function, aptly named int. So let's do that. Let's say int, open parentheses, and then we want to close that parenthesis. We'll do the same with the power variable. And note, I'll write this in a comment, we could have made result equal to int base raised to int power. That would have had the same effect. However, if we wanted to use base and power later in our code For a separate calculation, we would have had to convert to an int again. So in this case, and in most cases, it does make more sense to just convert as soon as you get the variable from input. Let's run this code again and exponentiate 2 to the power of 3, which gives us 8, which is correct. Okay, let's move on to example 2, which says to write a program that gets the remainder of an inputted number x divided by 2. Typically, we don't want you to name your variables x, but in this case, we'll allow it. So we'll name x the variable, and we'll set it equal to, and we won't make the same mistake as last time. We'll convert this to an int. We'll say int input, enter a number. Hopefully you remember the remainder operator. This is called modulo. Also, you'll hear modulus, or most commonly mod. And this operator is the percentage sign. So all that's left to do is print x mod 2. Let's enter in 4, and we get 0. So 2 goes into 4 twice with a remainder of 0. And if we try again with 5, 2 goes into 5 twice with a remainder of 1, so that checks out. Now there's an interesting pattern here. If I enter some arbitrary odd number, it'll give me 1 when I mod by 2. Let's try the same with some arbitrary even number. It gives me 0 when I mod by 2. Hopefully you're seeing this larger pattern. If we mod some number x by 2 and it equals 0, it's even. If we mod some number x by 2 and it equals 1, it's odd. This mod operation will always give us 0 or 1 in this case, and this comes in handy later. Okay, so example 3 says to write a program that finds the circumference of a circle, taking the radius through user input. So I'll be a good programmer and comment what I'm trying to do. For myself and for others reading the code, I'll say circumference is 2 times pi times radius. Now we know we need to get pi and radius somehow. So let's get radius in through user input. And you may think that this needs to be an integer, but we actually want to use a float because radii typically have decimal values, right? So we'll use a float because that represents a decimal number. And then we'll take in input as usual. So we'll say enter the radius of your circle. And I'll make a variable for pi next. Note that this is implicitly a float because it has a decimal value. And also note that I named this an upper snake case, which is the convention for naming constants. So we want to note to ourselves and to other programmers that this value should not change. And that makes sense because we know pi is 3.14, and that shouldn't change. And if we had multiple words in this variable name, we would separate them with underscore. That's why it's called upper snake case. Finally, this code sort of writes itself. So we can say circumference is 2 times pi times radius, and we'll print the circumference. Let's enter a radius of 2, and we get 12.56, which is correct. Okay, that's it for this video. Hopefully you have a better idea of variables, inputs, data types, and operators. Be sure to ask the course staff for help if you need it, and we'll see you in the next video.